Hello and welcome to this lecture on integral calculus. In this video, we are going to see about the changing the order of integration in double region. So, previously we have solved the problem by changing the order of integration in single region. Here, from the given problem, from the given limits, we get two possible regions and we have to evaluate the given function over the integral. So, the same procedure, what we will do, we will first evaluate the inner integral. Before that, we may take the limits. The y varies from x square to 2 minus x, and the x which has a limit of constant. So it is in the correct form, so we may do the problem here. So the limits x varies from 0 to 1 and y varies from x square to 2 minus x. These are the given limits. So from which we can make a region. How do you draw a region? Before that, we want to know about this. If I am plotting the limits, the lower limit will be x square and the upper limit will be 2 minus x. As same, if I take x 0, x equal to 1 from the given limits, just see, from this we have to draw a graph. How it is possible? First of all, how do you draw a graph for this equation y equal to x square? Simply, already we have studied x square equal to 4ay, which implies a parabola which open upwards. X square equal to minus 4y, which implies that parabola in downwards. As same, y square equal to 4ax, which implies on the open rightwards. Then y square equal to 4ax with the negative sign, then it will be open leftwards. So from this, it is matched with the value x square equal to 4ay. So of course it is a parabola. So clearly it is a parabola. So now we may take this line equation. This can be written as x plus y equal to 2. From this, if I substitute x equal to 0, then I will get the value y equal to 2. If I substitute y equal to 0, then I will get the value x equal to 2. From this, I am getting the 2 points 0, 2 and 2, 0. So with this, clearly we can draw a line, and remaining x equal to 0, it is the y-axis, and x equal to 1, it will be parallel to y-axis. And the next, what we did, y varies from x square to 2 minus x. So 2 minus x, 2 minus x means x equal to y, of course it is 2, of course a linear equation, so we may get 2 points. So while plotting these 2 points, I am getting the line. So just see, y varies from x square to x square to 2 minus x. Of course, this is the line at 2 minus x. You just see here, x square will be a parabola. So x square means it is a parabola. So these are the regions. And of course, it is up to y varies up to 2 minus x. Therefore, it should be lie below the line. So, y varies within this region because it starts with the parabola and it gets below the line up to the 2 minus x. Up to 2 minus x. So, this is the region for y from the limit of y. Next, if you go for the next value, x will be from 0 to 1. So this will be the graph, a line, a y-axis 0, and this will be the x equal to 1. Then this will be the graph. So x varies from 0 to 1. X varies from 0 to 1. So how it varies? 0 to 1. So 0 to 1. The whole thing. So if we can clearly see the overlapped region, this will be a shaded region. The shaded region will be a overlapping area. So therefore we have to evaluate this given function within this area. So this will be the overlapping area. So we have to evaluate this function. So first, what they have given here clearly they have mentioned is dy dx. dy dx. So dy dx, after changing, because our problem is to change the order of integration. So if I change the order dy dx, then I will get the resultant as dx dy. Dx dy represents horizontal strip. So just let me draw a strip here. If I draw a strip over this, if it is of horizontal strip, we have to see the limits from left to right. Of course, it is parallel to x-axis. So here the equation will be x equal to 0. So first we have to start with the left end. So here the strip is joined with the line x equal to 0 and the right end joins with the line y equal to x square. So once if anyone draw a strip here, then there is a possibility of getting another region, another limits. So the lower end here it is 0, x equal to 0, but here if you move over to the right end, it joins to the line x plus y equal to 2. So here we are getting two different limits. So from this point, it is divided into two regions. So here the value will be y equal to 1. Therefore, the value of y split the given region into two, from 0 to 1, another is 1 to 2. So here 0. So 0 to 1 is a region 1, and 1 to 2 is another region R2. So this point 1 comma 1 will split the given region into 2. So we may evaluate it separately. So we will get two limits. If I take R1, you will get the limit, because the strip is parallel to x-axis. Now first we want to find the limits of x. So x limit will be 0 to square root of y. So for this region, we will get the limit x equal to 0 and x equal to square root of y. If you go for this region, you will get the limit x equal to 0 and x equal to 2 minus y. So accordingly, we have to find another limit for the variable y. So just see this first region, the y varies from 0 to 1. So for this region, y varies from 0 to 1. If I go for this region, that y varies from 1 to 2. Therefore, for this region, y equal to 1 to 2. So these are the limits for each region. So we will do with the procedure. The given order is dy dx, so we have to change the order of integration. So we get dx dy horizontal strip. Already we did in the given diagram. I hope you understand. And see, y varies from 0 to 1 and 1 to 2, and x varies from 0 to root y and 0 to 2 minus x, what I told in the previous thing. Okay, so with this we will get two integrals with the same function. Now the order is changed into dx dy. Previously it is of dy dx, it is given, this is changed, altered. So now we have to evaluate each of the regions separately. So I may take this as I1 and this as I2. So I1. So simply it is a function xy with respect to x. X varies from 0 to root y. So what you will do? First we will evaluate the inner integral. Then x with respect to x, and then we will get x square. Then you have to apply the limits from 0 to root y. Then at last you will get the value y by 2. So now we have evaluated the inner integral. Now we want to make a substitution of this y by 2 to this part to go for the outer integral. So then if I substitute this value y by 2 to this equation instead of this inner integral, and then I will get the value y into y by 2, so it will be of 1 by 2 into y square. Then simply you will get what you will get on the next step, 1 by 2 integral 0 to 1 y square dy will be 1 by 2 y cube by 3, then 0 to 1. Then you have to apply the limits, then you will get 1 by 3. So as it given here 1 by 3, then at last the solution will be 1 by 6. So finally you get the integral answer for the first region. Now we have to go for the second region, that we call it as I2. So here it is of one integral from 1 to 2, then 0 to 2 minus y. The limits of x will be 0 to 2 minus y, the limits of y will be 1 to 2. Now the same process we will evaluate the inner integral part with respect to x. With respect to x, the y remain a constant, so we kept the y outside the integral. So on the next step we will substitute the limits after integrating the x with respect to x. So it will be of x square by 2. So for the x value we substitute the upper limit to the lower limit. Lower limit is 0, so nothing will happen. Simply the upper limit it will be of 2 minus y the whole square. So here 1 by 2, I am taking that constant 1 by 2 outside of the integral. Then remaining it will be y into 2 minus y. Well, may apply the formula a minus b a whole square. So we may get that 4 minus 4y plus y square into dy. So on the next step, we will multiply the value of y to this term. We get this step. On the next, we may integrate this. So simply y with respect to y na y square by 2. Y with respect to y square na it will be y cube by 3. Y cube with respect to y na y power 4 by 4. So then we have to substitute the limits. If I substitute the limits, first for the value y equal to 2, I am getting the resultant as 4 by 3. Then for the lower limit, I am getting the value as 11 by 12. So finally, if I subtract both, then I am getting the value 5 by 12. Therefore, we get this integral part, this without multiplying 2, we get this part as 5 by 12. This part as 5 by 12. So if I substitute this 5 by 12 in this place, then it will be multiplied with 1 by 2. Finally we get 5 by 24. So now we have find the value of I1 and I2. So finally we have to add up the both values. So we get I1 equal to 1 by 6, I2 equal to 5 by 24. While adding up that to get a total integral, so finally we get 3 by 8. So this is the final value. And next exercise problem. Again, of course it is a double region. I have given the answer for two regions, and final answer will be 1 by 3.